The most exciting thing about Europa can be summarized in one word: water. Now think about all the water on Earth and double that. That's what we think is on Europa.
We need to go there to explore it, to understand, is this place a habitable environment that could potentially support life?
Getting close to Europa is a huge challenge. It sits in the worst possible radiation environment, trapped by Jupiter.
Europa is a moon of Jupiter, about the size of Earth's moon, which has an icy surface that probably hides a subsurface ocean.
Scientists think Europa has the key ingredients to support life as we know it. Number 1, water. Number 2, energy. And 3, essential chemical building blocks. For the first time ever, we're sending a spacecraft completely dedicated to studying this moon.
The three main things that we're going to explore at Europa are the ice and the ocean, and understand that intersection between the two. Study the chemical composition of the moon, as well as the geology and whether it's active currently.
Europa Clipper is not specifically a life search mission. We're going to understand the potential habitability of Europa. The spacecraft has 9 instruments and a gravity science investigation. 5 of the instruments are called remote sensing instruments because they measure light reflected off Europa, like a camera or a spectrometer. The other 4 instruments are measuring the environment around them, like sniffing gases or dust.
Europa Clipper is the largest spacecraft NASA has ever built for a planetary mission.
It weighs 13,000 pounds, 6.5 tons. That's like the size of a huge African elephant.
And the solar arrays are massive. If you put the solar arrays at the toes of the Statue of Liberty, the other end of the arrays would come up to the Statue of Liberty's crown.
So not only are they big, these things are technological marvels. They are being bathed in radiation all the time, and they have to survive the entire mission like that.
Jupiter's radiation environment is intense, and Europa sits in the worst part of that environment.
Jupiter acts like a giant particle accelerator. There are charged particles trapped in Jupiter's magnetosphere that rotate with it. And these particles slam against Europa and will slam into our spacecraft as well.
We protect the spacecraft in 2 ways. Number 1, we try to minimize the amount of time we spend in there, which is why we are orbiting Jupiter and just flying by Europa. The second way we protect against the radiation is by having an electronics vault that we put our computer and some of the other sensitive electronics inside, which is made of about 1/3 of an inch of aluminum.
With each flyby of Europa, the outside surface of the spacecraft sees the equivalent of 1 million chest X-rays, just as we're flying by.
It's a pretty long trip to get to Jupiter from Earth, but not that bad from a planetary standpoint.
From launch to the time we get to Jupiter is about 5.5 years. And along the way, we have a flyby of Mars and then another flyby of Earth to get gravity assists to slingshot the spacecraft out to Jupiter.
I hope for the future explorers who are watching this at home that they take away from this that humanity, when we come together, can achieve really cool things.
This mission has been a long time coming, and we're so excited about what we're going to see when we get there.
We are in a golden age of robotic spaceflight exploration. How could you not be excited about something as monumental as this?
I am most excited about the potential to unlock the secrets of Europa, the potential to really understand this crazy world that exists and has likely existed in this condition for 4 billion years.